Example 9. The length of a rectangle is given by 6t plus 5, and its height is the square root of t, where t is time in seconds and the dimensions in centimeters. Find the rate of change of the area with respect to time. Alright, so we have a rectangle. And the length of the rectangle is 6t plus 5. And the height of the rectangle is the square root of t. Okay, we want to find the rate of change. So anytime you see rate of change, that's talking about derivative. Okay, and we want to find the rate of change of the derivative of the area with respect to time. So time is t. We know to find the area of this rectangle, it would be h times the length, the height times the length. So let's figure that out first. The area is the square root of t times 6t plus 5. Okay, and if I wanted to, I could write this as a function. A of t equals the square root of t times 6t plus 5. Okay? Alright, so we want to find the rate of change of the area. So how is the area of this rectangle changing with respect to time? So we need to take the derivative, a prime of t. Okay, in order to do that, we're going to have to do the product rule, where this would be considered the first and this would be considered the second function. So it's going to be the first times the derivative of the second plus the second times the derivative of the first. So hopefully you see where I'm getting that, where this is okay. So now let's simplify this. A prime of t equals 6t to the 1/2 power plus, if I distribute here, this is going to be 3t to the 1/2 power plus 5/2 t to the negative 1/2 power. And then you could combine like terms here. We can make this 9t to the 1/2 plus 5/2 t to the negative 1/2 power. And that would be the rate of change of the area with respect to time. Okay, let's look at this problem here. It says evaluate derivatives. Use the graph of f and g. So we've got this graph here in yellow. Call that f. And then we got the graph g right here. And we're going to let p of x equal f of x times g of x. And we'll let q of x equal f of x divided by g of x. So remember that if we take the derivative of f of x times g of x with respect to x, this is just the product rule. So it would be the first times the derivative of the second plus the second times the derivative of the first. And then if we're taking the derivative of the first divided by, the derivative of f of x divided by g of x with respect to x, that would be the numerator times the derivative of, the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. This would equal p prime of x, and this would equal q prime of x. So now we're going to use this information to find a and b. So looking at a, we want to find p prime of 4. So p prime of 4, we're going to use this. So we're going to use f of 4 times g prime of 4 plus g of 4 times f prime of 4. So first of all, f of 4, if you look at f of 4, that's going to be 8. Okay, so that's going to be 8. Next, we're going to do g prime of 4. So we're going to find the slope of the point right here when x is 4. So basically we're going to find the slope of this line here. Well, it's up 1 over 2, so this would be 1/2, plus g of 4. G of 4 would be 1, times f prime of 4. So the slope of the tangent line right here is 0. So this would be equal to 4. Next, let's look at q prime of 7. So this is going to be g of 7 times f prime of 7, and I'm using this guy now, minus f of 7 times g prime of 7 all over g of 7 squared. So let's erase some of this stuff on here, just so it's not so confusing. Alright, so now 7 is right here. So first of all, g of 7 would be 4. F prime of 7. Okay, so the slope that's going through here is up 2 over 1, so 2. F of 7 is still going to be 4. And g prime of 7 would be this line. That's going to be negative 1 because it's down 1 to the right. All over g of 7 squared. Well, we know g of 7 is 4 squared. So let's see, the numerator would be 8 plus 4, which would be 12. The denominator would be 16. So this would simplify to 3/4.